Okay, let's solve this example 1, and the question is a consolidate drained triaxial test was conducted on a normally consolidated clay, and given that sigma 3, which is 16 pound per inch square, and deviator stress, this is deviator stress, and this is minor principal stress. And the question is determine angle of friction phi prime and angle theta that failure plane makes with the major principal plane, and find the normal stress, which is phi sigma prime, and the shear stress, which is tau f on the failure plane, and determine the effective normal stresses on the plane of maximum shear stress. Okay, as our question is for consolidated drain test, so please remember that for drain test we have to use sigma 3 prime and sigma 1 prime, and for undrained test we have to use sigma 3 and sigma 1, and also memorize or remember for drain condition sigma 3 prime equals to sigma 3. So basically I just said that for drain condition we have to use sigma 3 prime, sigma 1 prime, and for undrained condition we have to use sigma 3, just sigma 3, and just sigma 1. Yes, okay. And for drained condition sigma 3 prime equals to sigma 1 prime equals to sigma 1. Okay, okay. Our question is about drain condition. Okay, and given that sigma 3 equals to 16 pound per inch square, and determine angle of friction phi prime. Okay, as we know, for drain condition we will use sigma 3 prime and sigma 1 prime, and the formula is, this is the formula for drain condition: sin phi prime equals to sigma 1 prime minus sigma 3 prime divided by sigma 1 prime plus sigma 3 prime. Okay, but we have sigma 3 equals to 16, but we don't know sigma 3 prime equals to what. But here the formula needs to sigma 1 prime, sigma 3 prime. But I said for drain condition sigma 3 prime equals to sigma 3 and sigma 1 prime equals to sigma 1. So they're given that sigma 3 is 16, so sigma 3 prime will also 16, as our question is drain condition. Okay, okay, let's calculate. Sigma 3 is 16, so this will also sigma 3 prime, and deviator stress is 25. So sigma 1 will, the formula of sigma 1 is sigma 3 plus deviator stress, so 16 plus 25, which is 41. Okay, as the condition is consolidated drain condition, so sigma 1 equals to sigma 1 prime. Okay, okay, sigma 1 prime equals to sigma 1, sigma 3 prime equals to sigma 3. So sigma 1 prime will 41 and sigma 3 prime will 16. Okay, then we get phi prime is 26 degree. Okay, okay, angle of friction phi prime is 26 degree. Okay, the next question is angle, find the angle theta. I just draw a more circle. This is center. Okay, and this is phi prime. So if this is phi prime, this also phi prime. Okay, and draw a line. This is sigma 3 prime and this is sigma 1 prime. Sigma 1 is major and sigma 3 is minor. Okay, okay, and it creates a triangle here. This is 90 degree. Okay, this is 90 degree and this is 5 prime. Okay, so what will this value? This value will 180 degree minus 90 degree, 90 degree plus 5 prime. Okay, so this value will 90 degree minus 5 prime. And remember, this is always 2 theta. So we get this value is 90 degree minus 5 prime. So this value will 180 degree minus 90 degree minus 5 prime. We get this is 90 degree minus 5 prime and this is 2 theta and the total angle is 180 degree. So 180 degree minus 90 degree minus 5 prime. So the result will 90 degree plus 5 prime. So this is 2 theta. So theta will 45 degree plus 5 prime divided by 2. Okay, okay. So find the angle theta. So the formula is 45 degree plus 5 prime by 2. So theta will 58 degree. Okay. Okay, the next question is find the normal stresses 5 sigma prime and shear stresses tau f on scalar plane. Okay, the formula of normal stress is phi sigma prime equals to sigma 1 prime plus sigma 3 prime divided by 2 plus sigma 1 prime minus sigma 3 prime divided by 2 into cos 2 theta. We get theta is 58 degree. So insert this value and we get the normal stress is 23 pound per inch square. And we also know the formula of shear stresses. This is tau f shear stresses and the formula of shear stresses is sigma 1 prime minus sigma 3 prime divided by 2 into sine theta and theta is 58 degree. So shear stresses will 11.2 pound per inch square. Okay. Next question. Determine the effective normal stress. The normal stress is sigma n on the plane of maximum shear stress. So, what is the maximum shear stress point? The Mohr circle. This axis is for shear stress, and this axis is for normal stress. So shear stress is increasing, and then shear stress is drops. So the maximum shear stress point is here. So this is point normal stress and shear stress. So this distance is normal stress, and this distance is shear stress, which is maximum shear stress. So the question is, determine the effective normal stress on the maximum shear stress. Okay, so we have to find out the normal stress. Okay, we know this is 41 and this is 16. 41 is sigma 1, sigma 1 or sigma 1 prime, and sigma 3 prime is 16, whatever. So this is 41 and this is 16. If we subtract 41 minus 16, then we get this value, and then divide with 2, then we will get this value. So this is 41 and this is 16. If we subtract from 41 minus 16, then we get this value, which is the diameter of this circle, half circle. This is diameter, then divided by 2, then we will get this radius value. Okay, this will 12.5. Okay, this is 12.5. So, and this value is 16. So we have to know sigma n normal stress value, which starts from 0, then ends with this point. So this is 12.5 and this is 16. 12.5 plus 16 equals to 28.5 pound per inch square, which is normal stress in maximum shear stress.